And here we go. We have liftoff. Propulsion continues to be nominal.
RCPA chamber pressure looks good.
Probably not. Roger, with planet.
Water towers fly! Yes!
Tango down to nominal.
Flight downside FT off. Bring in FT off. It's orange!
145! Oh my god! Oh my god!
Decollage. Put that in the big bag, Jingle.
343 unfolds to go.
Indeed.
We rise together, back to the moon and beyond.
If there's methane to be igniting in the flare, correct?
Yikes. You bet. We don't need any more of these.
Good evening. You are taking a live look right now at Space Launch Complex 40 at the Cape Canaveral Space Force Station, where we have Falcon 9 sitting on the pad ready for another Starlink mission. This one is Starlink 6-62 on board 23 more Starlink V2 mini internet satellites. I am Sawyer Rosenstein. I will be your host for this evening. And I love already seeing the 5x5s in chat, and that people already want me replaced by my cat Jake. But nope, sorry, you're stuck with me tonight. I am Sawyer Rosenstein. But thankfully, you don't have to listen to me the whole time because I have a fantastic team joining me tonight, including Mr. Trevor Sesnick. Trevor, how's it going?
Yeah, I can't complain, I must say. Seeing the Starlink 6-60 launch is super weird. I didn't think they would get this high, but excited to be here.
Me 6-62.
Yeah, but like the fact that it's in the 60s.
Yep. That.
Oh,
And on that note, also joining me in the field, I'm so sorry, Julia Bergeron.
Good evening, everybody. It is a gorgeous night on the Space Coast. I have a waterside view and snacks by my side and a lovely group of people joining us on the stream.
There we go. And always love to see people out and about. Occasionally get messages from you guys that you're out there watching the launch, and hopefully some of you are sitting alongside the roadways along Florida Space Coast getting ready to view this particular launch. And behind the scenes today, pushing the buttons, pulling the levers, pulling all of the... pushing the buttons, pulling the levers, bringing all the photons to you is Mr. Patrick Cahoon. And we can't forget, of course, our field team that is also bringing you all the views tonight, and that includes Max Evans and D. Wise. Reminder, if you have any questions, you can tag us at NASA Spaceflight, and we will do our best to answer as many of your questions as we possibly can. But let's start things off tonight, Trevor. If you don't mind, if you could give us a quick overview of this particular mission.
Yes, of course. So as you alluded to earlier, and alluded to by explicitly stating, this will be the Starlink Group 6-62 mission carrying another 23 Starlink V2 mini satellites into low Earth orbit. It is back to the usual 284 by 294 kilometer initial orbit, and then they'll spend the coming months raising up to that roughly 550 kilometer circular orbit, all inclined 53 degrees. And that is worth noting because we did see that one mission, I can't remember which one it was, that where they had the initial orbit be a little bit higher. They are not doing that on tonight's mission. It's back to the normal orbit. But yeah, as you can also see on screen, it is lifting off from Space Launch Complex 40 at the Cape Canaveral Space Force Station, and the booster is B1080-8. That booster's flown 8 humans and now will add another 23 Starlink satellites. Julia will go through the history of the booster here in a second. Following liftoff, it will attempt landing on SpaceX's drone ship, a Shortfall of Gravitas, and those two fairing halves will be recovered by Bob. If all goes well, this will be SpaceX's 339th Falcon 9 mission, 311th booster landing, and 200 37th consecutive booster landing. Will also be SpaceX's 54th launch of 2024 and 282nd reflight of a booster. So those stats are just kind of bananas at this point.
And that is what makes it not just your ordinary Starlink. But the booster tonight, as you mentioned, is B1080, and we also have, of course, a drone ship downrange. Julia, do you mind filling us in on all of that, please?
Absolutely. So the drone ship of choice tonight, wow, that's a tongue twister. Sorry about that. A Shortfall of Gravitas. And the tug that brought it out there is Signet Warhorse 1. We look forward to hopefully tomorrow night. Obviously, we'll see the return of Just Read the Instructions, which was taking a vacation dry dock with a few much needed little touch ups before going back into service because it's been busy out there for these drone ships. This booster 1080 is taking its 8th flight tonight. It's been about a 34-day turnaround, and we've flown on Axiom 2, Euclid. Let's see. Axiom 2, Euclid, Starlink 611, Starlink 624, Axiom 3, CRS 30, and Starlink 652.
There you go. And 6-52, by the way, was back on April 18th. So we are talking a very short turnaround there, although not its shortest, but just over a month between launches for this particular booster.
34.16 days.
But who's counting, right?
So this is actually a fun disagreement that Alex and I have. So I only go to two significant figures past the decimal point because I don't want to deal with when the booster lands. Because in my opinion, the turnaround time should be calculated from landing to the next launch. Since obviously when it's in flight, it's not like it could be doing another flight. When Alex thinks that's silly and a waste of time. So that's why I only go to two decimal places, whereas Alex goes to the second. But I disagree with the way Alex does his, so boo Alex.
We still love Alex, but it's a good thing that he can't respond as he's, I believe, on his way to the official NSF meetup in Leicester coming up in a couple days here.
Yeah.
Let's see. We've already had some crazy support before we even started the stream. Wilbo Baggins, thank you for becoming a Pad Rat member. Bartsy, thank you for becoming a Red Team member. Oh, we got Wilbo Tiberius and regular Wilbo Baggins, both Pad Rat members. And Just Done, thank you for becoming a Capcom member. Reminder, Capcom and above gets access to our NSF Discord. Here's a good question from Aeroplane Specialist, and Trevor, I will pose this one to you. They said, I saw there is no stubby nozzle today. Yes, I agree. But what is the difference between the stubby nozzle and the full-sized MVAC that we have tonight?
Yeah, it's a good question. I fully agree that thankfully it's not on today's mission. And thankfully Max is not on commentary to disagree with that. Um, so the main difference between the stubby nozzle and the regular nozzles, as the name implies, it's shorter. And what that means is it requires about a quarter as much of the niobium to manufacture. And that element is quite hard to come, or it's quite hard for them to manufacture this. So using less of that material is advantageous. But of course, this comes with a few downsides, if you will, and that's since you have a shorter nozzle, you're going to have some cosine losses in the exhaust, in the velocity of the exhaust, where it won't be going out perfectly parallel to the rocket's motion. It'll be going out a little bit more sideways, and those are called cosine losses. And then you also have a slight decrease in ISP since you have less time for the high pressure to be converted into high velocity. the exhaust velocity is lower on this nozzle. And since the exhaust velocity is lower, that means it's going to have lower ISP, since for rockets, ISP and exhaust velocity are exactly proportional. Um, so those are the two main differences. So on missions like Starlink launches, where SpaceX needs all of the performance that they can get out of the vehicle, they elect to use the full nozzle. However, on missions where they don't need the full performance of the nozzle, such as some of the CRS missions or really light payloads, they do elect to use that shorter nozzle.
There you go. Even getting into the scientific reasons behind it there. Uh, Here's a question, and Julia, I'm gonna end up putting this one to you. They said yesterday's Falcon 9 landing, I believe they mean the NRO mission out of Vandenberg, seemed to be a bit hard, and the landing legs appeared much more spread out and flatter than usual. Is this normal? Are the legs damaged? I know you didn't see that particular launch, but let me put it this way, Julia. What is in place to protect the legs and the booster from a hard landing?
Ooh, there's a couple things we can talk about here. You are correct, though. I did not see that launch. I was still sleeping. But I can tell you that the last launch we saw, which was the 21st flight of a booster from here, um, appeared to land hard as well. And I was pleasantly surprised when it came into port to see it quite very much upright. And there's a couple reasons for this. One, what you're referring to is crush cores in the legs, which help absorb some of the shock of what could potentially be a hard landing. And hard landings sometimes happen just because the ocean is rough. And it's possible the drone ship just kind of took a little bit of you know, just a little bit of motion, and it's the leg, one leg absorbs that. But should this happen and it appears that the booster is a little bit lower to the deck than you would like because it's harder for Octograbber to get under it, SpaceX actually has put in basically kind of self-leveling legs, which will aid in getting Octograbber underneath and stabilizing the booster. And that is not necessarily on some of the older boosters, but these newer ones do have that, and that helps bring them back safer, which is yay.
Yay, indeed, yes. And some of the boosters out west are some of the newer kind as well that do have that leg leveling, unlike some of the older boosters we saw, such as B1058 RIP. But, yeah. Let's see
I
here.
hate to say
our
that.
Go ahead,
Oh,
Julia.
go ahead, Trevor.
Oh,
no, why don't you go first?
Okay, how about this? I hate to say it to you, Sawyer, but I don't think self-leveling legs would have helped B1058 in that scenario. It was rough seas and broadside waves. So, unfortunately, no, even if it had it, I think the same outcome would have happened.
one can hope, okay?
And I was just going to point out that our understanding is that some of the older boosters are getting retrofit. So, right, SpaceX has been undergoing these sub-block upgrades with Block 5. Unfortunately, we don't know the exact time when these legs were introduced, but we believe it was on one of the most recent sub-blocks. And then SpaceX can fairly easily go and retrofit this change to the older sub-blocks of Falcon 9.
There we go. I do want to thank some more support that we've been getting here. Coco Cats, thank you for gifting a Red Team membership. Uh, like I was mentioning at the top, hopefully there are some people out there that are watching here. Kyle saying, I'm in Titusville for my first launch. Better not mess this up for me. We hope not to. And if they do, hashtag blame SpaceX. But hopefully you get to enjoy your first ever launch. Adam Swenson saying, how is the intro so hype every time? I don't know. It hits right every time. And the Musical Wolf saying, can we get some not an ordinary Starlink merch? Adrian, we'll need to get on that.
You know, that's a really grand idea, to be honest. With Starlink being the main chunk of what I see launching, I'm on
Yeah.
board with that ways.
Well, let me translate robot for those who might not have heard. But yes, with that being the majority of what's launching lately, that might not be a bad idea. So, yeah. Adrian! He's the man to go to with the store ideas. Let's see here. Here's a follow-up question, Trevor, to your answer. Flexi is saying, if the material used to make the nozzle is so difficult to manufacture, shouldn't the second stage be retrieved? And it's not that they haven't tried.
Um, yeah, so this is a right, this is something that SpaceX has actually looked into multiple times on Falcon 9. Originally, the second stage was supposed to come back and land propulsively, um, or sometimes not propulsively. Elon at one point joked about having it land on a bouncy castle in the middle of the ocean, which I don't know how serious that was. I'm guessing not, but who knows? This is SpaceX. And then more recently, I think it was probably in about 2018 or 2019, Elon made a post on X that was saying that they were going to basically try to turn Falcon 9 second stage into a mini Starship and add flaps and a heat shield for testing. And ultimately, the conclusion that they came to is this is just not worth the development effort. They need to take all of the lessons that they learned from Falcon 9 and put it into a clean sheet design architecture uh, where from the start the second stage was made to be reusable. And that led them to Starship. Uh, it really just comes down to Falcon 9 was designed primarily to be a partially reusable vehicle, and it would need major changes to become fully reusable, and there's no point in doing that when Starship is just around the corner.
That is very true. As NASA spaceflight official pointed out, Elon likes to joke about these kind of things. He even joked at one point that they would catch a booster with clamps and arms. Oh wait,
Flight 5 maybe.
maybe, hopefully? Question mark.
We'll see how Flight 4 goes.
Let's hope. And then also Gareth Cole very much wants to know: have you figured out who Gene Kranz is?
Yes, tune in to the Flame Trench on Friday. I will be on it. I watched Apollo 13 and I will discuss my thoughts.
Hey, good. I'm very excited to be on that show with you then. Uh, That's our on camera kind of weekly recap off the rails, Fridays at 5 Eastern here. And if you prefer more on the rails, we have This Week in Spaceflight that comes out a little bit earlier in the day on Friday as well. Uh, Here's one you've. I don't know if we have Julia back yet. Hopefully she's a little less robotic. If not, I'll still pitch this one to you, Trevor, just in case. Um, Rankley wants to know, is there a date yet for a crewed launch from Slick 40?
Ooh, that is a very good question. So we know that as of right now, Polaris Dawn is scheduled to launch from Slick 40, the very pad on your monitor. And the only real thing we know about that launch date is that it's early summer. So we're thinking that it's probably late next month, late June. But it also could very easily be somewhat earlier in July or mid-July. So I know that's not a date, but hopefully somewhere in the time frame of mid-June to mid-July is when we will see the first crewed launch out of Slick 40.
It's exciting, yes. We don't have the official launch date for that, but now we can actually say it's coming up very soon. And it is worth noting, a little bit earlier today on Space Coast Live, we did see what appeared to be a very wrapped up Dragon capsule on its way past our cameras and past the VAB. And as we tweeted about it, we did get a response to our Gavin, Space Offshore, with that picture. and it basically said, from Jared Isaacman, the commander of the mission, looking good. So, hopefully that means that the capsule is on its way out there and getting ready ahead of the mission. All right. Let's see here. Um, Interesting question from Hugh Mann, and it's kind of an opinion piece, I guess, in a way. Which flies first, Polaris Dawn or Starliner? I think personally it's safe to say it will still be Starliner, for multiple reasons. First off, the fact that Polaris Dawn, as we mentioned, is towards the end of June, and as of now, the latest date uh, is that they are targeting no earlier than June 1st for Starliner, but also the fact that that ISS mission, I think, will take priority versus a private mission, just my personal opinion. I don't know what your thoughts are, Trevor.
You know, it's hard to say. I have a lot of questions. So I must say, first of all, I fully agree with Eric Berger that NASA has not done a good job with updating the public with what's going on with the CFT mission. And I really don't understand how they went from having crew on the vehicle to minor delays to not having or to an indefinite launch date to within 24 hours from that having a launch date that's a week away. And this is all within the span of 2 weeks. um, so I really hope that NASA uh, updates the public and gives us a good idea of what's going on, and hopefully part of that is they really go over every single detail of why they wanted to delay the launch and why they think that it's safe to move forward. um, But I don't know. I won't lie. Starliner has not given me a ton of faith that it will be first, but I also wouldn't want to bet on Polaris Dawn. So right now, I feel like probably Starliner will go first, but I could so easily see that changing.
It's also worth noting that we will get an update as of now, currently scheduled for Friday at 11 a.m. There is a media teleconference, and NASA Spaceflight NSF, we will be in there to make sure that we get questions answered as well. Now, we are coming up here below T minus 38 minutes. So, in terms of where we are here in the countdown, at this point, that would hopefully mean that we should know whether or not they are go or not for propellant load. That verification begins, as mentioned, at T minus 38 minutes. You see there on the top of your screen. And if so, we should start to see frost forming on the booster at about T minus 35 minutes. That will indicate that the fuel load has begun, beginning with the RP1, the rocket propellant 1, which is a refined form of kerosene, as well as LOX, liquid oxygen, inside that first stage booster. We will also then see RP1 load into the second stage. The LOX is loaded later on in the countdown for that second stage, beginning at T minus 16 minutes. And of course, in between the RP1 load and the LOX load is the LOX chill down, which we know as the best vent, the T minus 20-minute vent. So hopefully, within the next few minutes, we should start seeing the booster get frosty, which will indicate they are continuing towards a liftoff tonight at 10:35 p.m. Eastern Time. I do want to address here, my goodness, there has been a gifted subathon going on while we've been talking here. Todd Johnson, thank you for gifting 10 Red Team memberships. Bideford, thank you for gifting 5. Ninja Decimator, pew pew pew. Thank you for gifting 5 Red Team memberships. And Miss Daisy, thank you for gifting 20 Red Team memberships. Holy smokes. Thank you very much. If you did get any of those gifted memberships, please make sure that you give them a big ol' thank you, and hopefully you can enjoy the perks that come along with it as well. And then Ken Schaefer coming in also now with 20 more Red Team memberships. Unbelievable support. Wow. Thank you. Thank you. Ooh. Here's a good question. Julia, do we have you back yet? Because this is definitely a Julia question if we have you. If not, I will save it in the queue for a little bit. believe we're still trying to get Julia a better reception so she doesn't come through as a robot, but instead as our insightful commentator. So we'll save on to a special Julia question then for later. Let's see. Another question then. Let's go to this awesome view, by the way, from our fleet cam there, as we are now under 35 minutes. Here's a good one then. Trevor, I'm just going to pose this one to you myself. In terms of the countdown, how come it's still at T minus 35 minutes they start fueling? Do you think at this point they could do it faster, or is this pretty much as fast as we can go?
Yeah, so before I answer that, I just want to say we now have official confirmation from SpaceX that propellant load has started and that all systems are go, winds are calm, and the clouds are keeping a respectable distance. Um, I must say,
Very nice of
I've
them to
kind
be
of enjoyed,
respectful.
yeah, I've very much enjoyed some of the personality in the SpaceX posts on X recently. Um, Instead of just for every launch being like propellant load has started, weather is good, throwing in, a bit of fun. Anyway, to answer the question, I suspect if SpaceX really wanted to, they could load the vehicle quicker. But again, it ultimately comes down to at what cost, right? We see Starship is loaded in, uh, similar, actually less time than Falcon Heavy, despite being over 3 times as much propellant. Um, and so it's definitely possible, but is it worth the development, right? Falcon 9 is a rocket that is, much to my dismay, going to be retired within the next decade, decade and a half, somewhere in there. Uh, so it's just the usual of, is it worth them putting more development resources into this vehicle? And what will the outcome of said development be? And my guess is if they've done the math, they've realized that it wouldn't be that big of an advantage to have a little bit cooler of lock. So the, it wouldn't be worth the development time and money when that could be better spent on Starship or Starlink or Dragon or any of the other systems. So I would be very surprised if we ever see uh, time or further significant changes to the propellant load sequence on Falcon 9.
Yeah, I mean, they've expedited things pretty fast as is here with the quick fill. And for those of you wondering in terms of the retirement, don't worry, you still have time to see Falcon 9 before it retires with, what, over 100 launches a year for the next 10 or 15 years. You still have thousands of opportunities to come down and see Falcon 9. All right.
Yeah.
I believe we now have Julia back. And Julia, I saved this question from Logan just for you. Uh, Logan wants to know, what is your favorite Falcon 9 booster? Theirs is B1080 because CRS-30 was their first in-person launch.
Ooh. Well, my favorite was B1058, but my second favorite was 1062 and is now my new favorite. Let's just say that that's a special booster, mostly because of the spectacular inspiration formation.
That booster also has 2 records on it. Not only the most launches and landings at 21, but also has the quickest turnaround at 21 days, 6 hours, and 10 minutes.
Let's just say I have a love of fleet leading boosters.
How
Yeah.
could you not? And as we approach T minus 31 minutes, we do indeed see frost forming on Falcon 9, confirming, as we saw from the tweet there, fueling is indeed underway. And no, it's not an earthquake. What is the weather like right there, by the way, Julia?
Well, the weather actually is gorgeous tonight, and the skies are pretty darn clear because I see a gorgeous moon and lots of stars. If you ask Max, the bug forecast is kamikaze. He's yeah. They like Max's ear tonight. So but otherwise, from any other spectator's point of view, not out in the swampy marshlands where Max is, it is a beautiful night.
That's what we love to hear. Beautiful night.
And
And the official forecast, by the way, in case you're wondering, the forecasts are created by the Range, which is operated with the 45th Weather Squadron, and Space Launch Delta 45, which is part of the U.S. Space Force. They gave the official forecast as a 95% chance of favorable weather for tonight's launch. Let's see. Here's we got 9-8 Central already asking, is Falcon 9 trajectory in the moon aligned for an awesome photo op just after launch? I don't think so tonight. If so, I'm sure we would have our team out there and trying to figure out the angles for it. But I guess, Julia, that also leads to the question of could there potentially at least then be a jellyfish tonight?
There could potentially be illumination by said moon. Yes, indeed. Sunlight illumination, jellyfish, like we saw last launch, that would be a no. The sun's far too well set for that. So I look forward to seeing what the moon glow does.
Yes, we have seen, as we call them, moon jellies before. They are a thing, and they are spectacular. Inspiration 4 also comes to mind for that one. Crew 2, I think it was. Crew 2 or Crew 3. Also spectacular ones of those. Here's a question from Fred, and Trevor, I'll put this one over to you. They're saying, how do they avoid all the space junk and satellites up there and not accidentally hit it with the rocket?
ooh, this is a good question. So there are several parts to this. The first is, right, if you look at some of the web tools where, right, they try to show you objects in orbit, while those are correct, they are somewhat, the scale is entirely wrong that makes it seem like a harder problem than it actually is, right? You have at 550 kilometers, you have a lot of satellites, right, on the order of, call it 10,000 plus some space junk, but you also have so much room up there that it really, at the end of the day, yet isn't that big of a deal. And more than that, moreover, when we have, well, the Space Force and other entities have good tracking of a large number of those objects. Not every single object. Some of the objects are too small that the Space Force is not tracking them. But um, and those are all in a database that is publicly available. So anyone can go and look at any object in orbit, see its position. So in the mission planning, you can kind of plan for all of this and choose T zeros accordingly, such that there are not any problems with that. However, it does every now and then cause a small delay to a launch. Like I remember there was a Rocket Lab launch a few years ago where they delayed by, I think it was on the order of a few minutes just to make sure a satellite passed over ahead of their launch attempt.
I believe the official term for those are cutouts that they have in the window, specifically for
Yes.
that exact reason of if there is a satellite overhead or some potential space debris conflict, that they will just not launch and wait a couple of minutes if they're able to try again. And
Another fancy acronym is COLA.
ooh, yes, and we're not talking about Coca-Cola. Do you know what cola stands for?
Collision, no, no, I just remember it being having colas in launches like SLS because there were moments in time that were not desirable. So if things changed, you had to, yes, you couldn't launch during those colas.
Which, by the way, it's just shortened for collision avoidance, basically.
Oh,
Yeah, collision
fancy that.
launch avoidance, cola.
There we go.
Not to forget its predecessor, Pepsi. Oh wait, no, that's something totally different. Sorry.
Let's not get into the Pepsi in space. No.
Oh god, the cola wars did go to space, but that's a
Yes,
story
they
for another day.
indeed.
I want to thank a bunch of people here while we have a moment. Uh, Deb, thank you for becoming a Pad Rat member. The gift train just continues, people. You're unbelievable tonight. You're leaving me wordless, and my job is to make words. Marcus Burnett, thank you for gifting 5 Red Team memberships. Alt Center, thank you for gifting 10 Red Team memberships. Todd Johnson again, thank you for gifting 10 Red Team memberships. Dan Elgin, thank you for gifting a Red Team membership. Goodness gracious. We've got 42 Spacebar asking, will there be any live coverage of the UK meetup coming up? I don't know if there'll be any lives, but I'm sure there'll be plenty of posts on social media, including X the Everything app. So I would keep an eye out for all of our NSF followers there. You also have Echo Deal. When the moon hits your plume and it makes the light bloom, that's a jelly. How'd I do? Do you think I should
That
try out for
actually
American Idol?
wasn't awful. That was very clever, Sawyer.
Thank you. Echo Deal wrote most of it, but next time I'll actually warm up my voice. Let's see. Mans on Mars also asking, how does NSF plan on covering neutron launches from Wallops? Well, wherever they allow us to watch it from, we will absolutely be there to cover it. I mean, that thing is going to be so cool when it does fly. As Electron is pretty darn cool flying from Wallops as is. So, we will cover it. Promise you that. Hopefully. Whenever that may be. And Roseanne DeVasto saying, been cool to watch you, me, Sawyer, rise from one of us nerds to a valued commentator. P.S. Congrats on your healthy looking weight loss. Congrats, dear one. Thank you. Wasn't the ideal way that I planned on losing weight, but I still appreciate it nonetheless. And Steve Alling saying, happy launch night. Planning a trip to watch Falcon Heavy. Is the date still June 25th? Well, that's a good question. As of right now, I believe the launch you're talking about for Falcon Heavy, which is the GOES U satellite, is currently scheduled for this upcoming June. And I believe that is still the current date. Correct me, Trevor, if I'm wrong.
I believe that's the current one, yeah. We have not heard of any delays. I believe we're expecting 2 more Falcon 9 launches out of 39A before we see conversions for Falcon Heavy, but it could just be one. I can't remember.
Speaking of LC-39A, there it is, as seen from our Space Coast Live cameras there. And yeah, also don't forget you can keep up to date with all the launches on the Next Spaceflight app too. I know Alex and the team at Next to Spaceflight do a great job over there, so props to them. Coming up now, T-minus 22 minutes and counting here. Let's see, when is Jake joining the stream? He'll get here eventually, don't worry. Will we cover the first launch in Scotland? Trevor, I'm sure we'd be in trouble if we didn't with all of our UK friends out there.
Yeah, I have no idea what, if any, live stream plans there are, but there'll absolutely be content on the news site, and who knows if we can get a pack out there with Chris or Jay or one of those people. I'm sure we would, but I don't want to make any promises since this is not my department.
Yeah, but don't worry, UK fans. Once you guys start launching rockets again, we will be trying to cover them as best as we can. Chris Bergen, NASA spaceflight official in the back channel, saying, I have a passport, so I could go. Good. Deal. Chris will be the one covering it then. Also, Apocalypse Cow, thank you for gifting 10 Red Team memberships. All right, folks, at this point, we should be coming up now near the end of RP1, Rocket Propellant 1 load on the second stage of Falcon 9. It will continue along with the LOX load on the first stage, but we will get a good indication of that with the famous T-minus 20-minute, 20-second vent. And as we are seconds away from that, Julia, can you kind of explain what this best vent is all about?
This best vent is a, well, It's a vent that clears out and purges the lines, correct, Sawyer? You'd think I would have this memorized by now after how many hundreds of launches, but it is a line purge because we do not want excess fuel in the line before we launch. And then it also signals that the second stage will be topping off.
Yep, that's when we also finish the LOX load too. The other reason, especially after the RP1, is to chill the line down because RP1, for those who don't know, with it being kerosene, doesn't have to be as super cooled as something like liquid oxygen. So it's closer to ambient temperature. I mean, it's still cold, but closer to ambient temperature, whereas the liquid oxygen is very cold. So you condition the lines so that you're not putting super freezing liquids through them after it being kind of decently warm and then run the risk of issues with your ground lines.
Yeah, that would be very bad for ground lines. I could see cracks happening. So, yeah.
And ground support equipment has never caused any issues whatsoever with launches, right?
Well, thankfully, not as much at these pads because they are very frequently used. I would like to think that frequently using something gives you a little bit less time between launches for things to go awry on you.
There we go. And the other interesting thing with this vent is that it gives you a really good idea of weather conditions out there too. 'Cause normally, you see this big giant cape coming off of it, that means that it's super windy. And as you can see, side by side with the flags there at the press site, it's a light breeze, which means you just get a little light kind of movement on that vent. Most of it kind of hangs around the base of the rocket, but some of it you can see a little bit moving with that very light wind there. Cool shot, Patrick. Here's another question then. Joe wants to know who will be able to see this launch and what is the launch trajectory for tonight? Trevor, where are we going tonight with this?
Yeah, good question. So as usual for the Starlink Group 6 missions, this is going to the south east. So the landing will be just north of the Bahamas for stage 1, and then it'll continue along that descending node of Starlink.
Yep, and there it is on
And
your screen
there,
now. You can see going right near the Bahamas and heading southeasterly. So anywhere along basically the Florida main peninsula, you should get a decent view of it, especially along the eastern coast there. Both a little bit north, like Daytona and St. Augustine, as well as south, down to the Palm Beaches, Fort Lauderdale, Miami. And then the second stage, once it's done with its job, it will deorbit as well. And that has its own map that they keep track of where those fall down. Again, all these are designed to hopefully not land on top of people's houses or people or dwellings in general, for that matter. Uh, Here's another one that I'll pose over to you, Trevor. Um, in terms of the deorbiting, what is the deal with this deorbit of the spacecraft, and what about deorbiting Starlinks themselves?
yeah, this is actually a great thing that we can lead into, Patrick, if you can pull up the footage. So this is some footage of what is thought to be a Starlink satellite re-entering. So what SpaceX does is once these satellites are at the end of their life, or if there are some problems with them, they re-enter them. But their satellites are designed in a way so that they fully burn up on reentry. So there's no debris hitting the ground. So that means that they can really deorbit them anywhere. And uh, our the space police himself, Jonathan McDowell, who is just absolutely phenomenal and doesn't get enough love in the space community, noted that this is consistent with Starlink 26, and Patrick just took it off screen. Hold on, let me pull it up. Satellite 2653,
It's there.
and
He's
is
vigorously
the
shaking the
deorbital
arrow.
plan. And this is all part of SpaceX is retiring 122 satellites from the V1 constellation. Thank you, Patch. I see it, Patrick.
Patrick Hart.
You should go in the store. So SpaceX is undergoing a fairly large retirement of some of the older satellites, about 122, which sounds like a lot, but also keep in mind that was 2 launches back in the V1 days. So it really isn't that big of a deal. And this is all expected, right? We knew that the satellites likely had an on-orbit lifetime of approximately 5 years. These satellites started going up approximately 5 years ago. So hence they're starting to be replaced. But even with this retirement, SpaceX has been still putting up a large number of them. So there are currently, it looks like 6459 satellites that have been launched, and 6,020 of those are in orbit. And SpaceX is also rapidly approaching the 6,000 mark for operation for working satellites on orbit. So this constellation is just crazy.
Bonkies, one might say, yes. But yeah, so 2653 is definitely one of the much older satellites, and this is kind of something we talked about at the very beginning of the program of Starlink going way back, is the fact that they're going to have to keep launching more and more satellites to keep up with the demand and keep up with the number as they re-enter. Because part of the design of Starlink is that they are kept in a very low Earth orbit. Which is great in terms of low latency for people using it, but bad in terms of atmospheric drag and the fact that, these satellites maybe 5-ish years or so lifespan before they end up burning up in Earth's atmosphere. So, if nothing else, it'll definitely keep Falcon 9 in business for a while as long as they continue to launch these Starlink satellites.
Yeah, so like you were saying, these missions are going to approximately, I think it's 550 kilometers circular orbit. I can never remember which shell is 530 and which is 550, but it's right around there. And that is quite low. So for comparison, all of the previous internet satellites that were on orbit were in geostationary Earth orbit, which is like 37,000 kilometers or something like that. And since C is a fixed value that unfortunately humanity cannot change, those photons can only move at C, and therefore having them closer to Earth is just going to decrease latency. However, going forward, SpaceX is going to have satellites in even lower shells. I believe they have filings for satellites that will be at 340 kilometers operational altitude, and those satellites will obviously have a lot shorter of a lifetime compared to the ones at 550, and just because there's more atmosphere.
And for those who don't know exactly what you mean, by the way, I always like to remember it as you can see light, so c is the speed of light.
Oh yeah,
In case you're wondering what we were seeing there.
it is equal to, I think, 1 over square root of epsilon naught mu naught. Is that
AKA
helpful?
fast. I think
Yeah,
pretty darn fast is the appropriate term for it.
pretty darn fast.
Let's see. Here's a good question. Kanan wants to know, Julia, do the Starlinks ever do engine burns?
That's a really good question that I may have to kind of ask Alex, because I do believe, well, they can basically, let me say they can do some kind of collision avoidance. They can get to their orbit. So yes, they do have the ability, as Alex says, they have Hall effect thrusters. So there is some maneuverability with them. And with so many things in orbit, part of our responsibility, humanity-wise, right, is when we put something in orbit, we want to make sure that we have the ability to avoid collision if possible, right? Because a lot of things can happen out there in space, but also to be able to deorbit our satellites safely, as we were talking about earlier. Ideally, to bring them into a graveyard or an area where humans do not reside. So, putting thrusters on any satellite going up is kind of the responsible thing to do now.
And if I recall,
Yeah,
with
and
those Hall effect thrusters, they actually used a different material originally, but they were
yep,
worried
it
that
was
was
krypton.
going to be gone, so rather than it being argon, they now use argon.
Yep, the V1 and V1.5 satellites were krypton, and then the V2 satellites are using argon. And both of these I don't think are super common. I think a lot of satellites use xenon for their thruster, propellant, and the ion engines. However, my understanding is xenon is very expensive and kind of hard to come by. So SpaceX elected to not use it, but I don't do chemistry, so uh, I don't know.
Yeah, again, all the chemistry jokes are gone, so I had to try and make my reference there. Sorry. Julia, if you want to leave after that, I totally understand, or just because of the fact that we're a little under 9 minutes now until the scheduled liftoff time, and I know you're probably going to want to get your camera set up.
Actually, Sawyer, tonight I'm going to join you for the whole thing. I'm in my backyard today. As I moved for Wi-Fi reasons. Home is where the Wi-Fi connects.
Wow! Ladies and gentlemen, you are getting a rare treat here, a constant communication from the field even during the launch. Julia, we're excited to keep you on.
I had to move to bring that to you, but I'm excited to be here. And my backyard really is that close. The time I was not on comms was the time I searched for signal and then gave up and came home.
Well, we're glad to have your really strong signal and have your strong voice tonight, too. Let's see here. Kanan with a second question that was really good that I do want to address here as we get to 8 minutes. They're asking, what's the number in the name mean? Is 6 an inclination? Is the batch from each launch a slightly different inclination? What dictates a new group? So basically, for those who don't know, why is this called 6-62?
Yeah, good question. So SpaceX has a number of orbits that they filed with the FCC of where they're going to put these satellites. And each one of these orbits is called a shell. And the reason why it's called a shell is because once you have a large number of them, it really does kind of look like it's a shell around the Earth. So for the exact shells are kind of messy. Since there are a lot of future shells that SpaceX has not begun filling yet. But so far, we've had shells 1 through 5. Shell 1 was 53 degrees at 550. Shell 2, 70 degrees at 570. Shell 3, 97.6 degrees at 560. Shell 4, 53.2 degrees at 540. And Shell 5 was 97.6 degrees at 560. And then there are and those are all of the Generation 1 shells. But then there are the Generation 2 shells, which is Starlink Group 6, Starlink Group 7, and Starlink Group 8 for now. And those are 53, 43, and 53 degrees respectively, if I remember correctly. So it all just comes down to the orbits that they are going to. Yeah.
And on that note, we haven't really had very many. When was the last time we had Starlinks that went north? Does anybody recall?
Ooh,
From the East Coast,
that
it's
was
been a very long time, right?
Right? I feel like we've been gypping the folks up in the Carolinas because we've had a lot of south and southeasterly, and we rarely give northeasterly flights except for like crew and cargo. So we're really sorry to those north of us. That used to be the more common view, actually.
yeah.
Well, the people in the Bahamas hopefully soon will get their chance as well once those start launching. In the meantime, though, we are getting much closer to launching here. We are now within 5.5 minutes of the scheduled liftoff time here tonight And at this point, the engines have been chilled down. The 9 Merlin 1D engines, which, why do they do that, Trevor?
Just like they don't want the line of the TE to be room temperature before flowing liquid oxygen through it for filling the second stage. They don't want the engines to be at room temperature when they flow liquid oxygen through them at engine ignition at T minus 2.7 seconds. So instead, they start running a little bit of liquid oxygen through the turbo pump in order to make sure that the engines are chilled down. So then, when they start that full uh, flow of propellant, they do not have the propellant immediately vaporize into a gas. That would cause a large volume expansion, and then you can damage your engine, have the engine hard start, and in some cases, even have the engine blow up. And that is not what you want. You really don't want your engines to blow up.
Definitely not. And we are now approaching T minus 4 minutes. And at this point, speaking of the strongback, the transporter erector there, the strongback should be slowly retracting. There's some clamps that move away from just underneath the fairing. Then it retracts a whopping 1.8 degrees away from the rocket. Don't worry, it will eventually throw back all of the way. But at least for the initial point of the liftoff right now, it is 1.8 degrees farther back. And apparently, we're getting info here from Alex in the back channel that the last northeasterly one was December of 2022. So this one, however, continuing
Alex,
to the southeast towards the
Alex is
Bahamas
such a
again,
nerd.
as we now hit
I
three
don't
and a
know if
half
I can
minutes.
comment, but
Anyway, so what can we expect here now, Trevor, in the final 3 minutes?
yeah, so the next big event will be at T minus 60 seconds, which will be when the vehicle will enter startup. So that's when the vehicle handles the countdown as opposed to computers on the ground side. Also, at that time, the tanks will begin pressurization for flight level. So they want the pressure to be, I think Falcon is like 3 or 4 bar, somewhere in there in the tanks, to ensure that they're structurally sound for when those 9 Merlin 1D engines ignite at T minus 2.7 seconds. Um, Following that, at approximately T minus 45 seconds, the launch director will verify that they are go for launch. At that point, no big events until T minus 10 seconds, which is the last point that a human can call an abort on the vehicle. After T minus 10 seconds, only automatic aborts are triggered. The vehicle monitors itself. If it sees anything it doesn't like, then it will abort the countdown. At T minus 2.7 seconds, as I've been saying, pay attention to the base of the vehicle for that bright green flash of T-tab aluminium triethylborane, I think. If I messed that up, I'm sorry. That is a pyrophoric compound, which means that when it contacts oxygen, it ignites. So they start by running that through the engines, and then they start with liquid oxygen and RP1 to ignite those 9 engines. Those engines are ignited in pairs to reduce transients on the vehicle. Following that, the vehicle will start ramping up all 9 of those engines to full power. Then it will check to make sure all 9 engines are healthy and that the vehicle itself is healthy. And if that is the case, it will command the ground launch clamps to release the vehicle at T minus 0 seconds.
And there you go. And that vent, by the way, is totally normal. That is final line purge of the liquid oxygen after LOX load was complete on the second stage. At this point, the vehicle is fully fueled with the RP1, rocket propellant 1, and the liquid oxygen in both first and second stages. Now that we are under 1 minute, as mentioned, the tanks are pressurizing the flight levels, and Falcon 9 is in startup, meaning that the onboard computers currently have control of the countdown. The next thing that we will wait to hear is that go for launch from the launch director. And if that's the case, then we will continue watching the countdown here all the way to T0 as we hit approximately T minus 30 seconds until launch. Looking at about 20 seconds or so right now. And we have the go for launch. 15 seconds. I promise we will be quiet once it launches so you can hear the sound once it reaches our microphones a couple miles away, as we are less than 10 seconds now. As Trevor mentioned, keep an eye on the base of the rocket for that ignition. There it is. And liftoff of Starlink 6-62. Go! Starlink V2 Minis, go! There we go. Vehicle continuing onward, passing through Max Q, maximum aerodynamic pressure on the vehicle, and moving through the speed of sound as Falcon 9 continues its way into orbit, 90 seconds into flight so far. Trevor, everything looking good.
Yeah, looking very good, and it sounded very good as well. We heard both that awesome launch audio and then also the VAB squeal, which I finally hear. I thought it was a lie for so long, but it's not.
Now, that squealing noise you heard was reverberations off the panels on the vehicle assembly building. We can get a little bit more into that shortly, but for right now, look at that engine trail, the beautiful colors on that as we continue to climb at T+2 minutes. In the next 20 seconds or so, we should have 3 events in rapid succession, starting off with MECO, which is main engine cutoff, the shutdown of those 9 Merlin 1D engines, followed shortly thereafter by stage separation, and then SES-1, which is second engine start 1, when the Merlin vacuum engine will ignite and help propel stage 2 into orbit. Look at that gorgeous blue color as it gets higher up there.
Yeah, that was awesome.
The SpaceX feed is a little bit behind ours, so you'll get to see certain things in replay form in a way here as we approach MECO. And we have main engine cutoff. There is that stage separation. And on the right side of your screen, we should see that engine bell get nice and glowing. And indeed we do. That is second engine start 1. So stage 2 continuing to propel those 23 Starlink V2 mini satellites into orbit. And you can see our ground cameras continuing to track that second stage. Julia, what's your view like right now on the ground?
It was a gorgeous view from the ground, and I definitely heard that VAB squeal loud and clear on comms tonight. And fun fact, just about when you all stopped hearing the sound on stream was just about when we could hear it here on the coast.
Wow. And there is a bit of that moon jelly there that you were talking about before. The moonlight hitting just right, and our cameras being just sensitive enough that you get to see a little bit of that expansion plume, the moonlight actually igniting it, as opposed to sunlight, which was the jellyfish that we saw the other day. In case you're wondering why it's called jellyfish, that is why, because it kind of does look like the head of a jellyfish once illuminated. And most of those white lights that you see there are stars, although that one on the left there looks like it is part of that first stage, continuing its return towards the drone ship downrange. So there is a view as well right now at the press site of both the remaining plume there and it continuing outward towards its southeasterly trajectory. Trevor, what do we have coming up next?
Yeah, so we have a series of events coming up. On the booster, the first burn will be the entry burn, and that is the burn that will utilize three of the engines on the first stage, engine 1, 5, and 9. And those three engines will start with the center one ignition, E9, before the outer two, and this will help slow down the booster. So if you see the telemetry in the bottom left, the booster is now falling back down. As you can see, the altitude is decreasing and the speed is increasing. At some point, the speed will get very high, and they don't want the velocity to be that high, so they start with the entry burn. Um, and that's coming up in about a minute and a half. And then after that, it will perform the landing burn, which will be just a single engine, which will hopefully take it to a soft touchdown on a shortfall of gravitas.
That is, of course, the goal. And in case you're wondering, Julia, which booster is this?
It is B1080, and this is its 8th flight. And is that the guys? Are we still tracking that? That's an amazing shot.
Yes, we are continuing to track that. Of course, the clouds giving us a little bit of issue there, but look at that. There we go. That appears to be the, I believe it's the entry burn, is it not?
It
Or
is a
that
clear
supposed-
night, so if you're
Yeah,
on the coast,
that's
that's
entry burn.
probably that.
We'll see if it shuts down now.
And
There
there
we
you can
go.
see it went down to one engine before. Yep. You could see it down select to one engine and then goes back to 0.
And that's how close it is to the horizon
we
for
have
reference there. You can see the launch pad. But yeah, that was the entry burn, where it fights fire with fire to help slow itself down as it gets closer to the drone ship landing. And there is our continued tracking of the second stage as well. And as Trevor mentioned, we should start seeing the landing burn begin within the next minute or less. And that will hopefully end with the booster landing safely on the drone ship downrange. That will be followed shortly thereafter by SECO 1, or Second Engine Cutoff 1, which is the shutdown of that Merlin vacuum engine. The reason it's called SECO 1 is because there is a second burn, but that doesn't happen until about 55 minutes after liftoff. Continuing to track stage 2 there, right to the horizon line. Beautiful track. And now let's see. Here's the onboard views. We should be seeing that landing burn coming up. Keep an eye on the left side of your screen for that. It's now already going slower than 1,000 kilometers per hour, the first stage, 3 kilometers off the deck. You can see that light there. That, I believe, is the drone ship. Kind of through the grid fin there.
It is.
There we go. You'll see those grid fins helping to steer the vehicle towards the deck of the drone ship. There it is. See it on screen. Landing leg deploy. And touchdown. Another successful SpaceX booster landing, this time B1080, taking the deck on a shortfall of gravitas.
And that's the 311th booster landing and 237th consecutive. 237 in a row. That's
all,
insane.
huh?
Must I say that that's an absolutely terrifying point of view from the booster at night, landing on a postage stamp in the middle of an ocean, and it is so dark out there, and all you see is water until it makes that final angle into the drone ship when it knows it's okay to land, and that is bonkers to watch.
Right, in case you're wondering, that is intentional of why it looks like it's not aiming at the drone ship, because it's not. It waits until the very last moment, as you mentioned, to make sure all the engines are running, everything is going smoothly, before it does that final turn to touch down gently. That way, if something is wrong, The worst thing that happens is you lose the booster into the water, as opposed to accidentally damaging your drone ship, which you can see based off of the cadence, they need all the drone ships they can get right now. And we are working on getting replays for you, so hang tight. I promise we'll have some really cool, awesome views. I mean, you saw how long we had that second stage, so we should get some amazing replays coming shortly here. I do want to thank some support that we got both before, during, and after the launch. Let's see. Spurgear, thank you very much for the support, creating their own creator clash with Scott Manley and Tim Dodd. Tyler, thank you for becoming a Red Team member. Durwa, thank you for gifting 10 Red Team memberships. Let's see. Katie with Max Coffee and Pun Tokens, just in case. Rocket Lab here supporting. Thank you, Katie. And then Anonymous getting a couple items from shop.nasaspaceflight.com saying, good work, y'all. And I agree. Great work to the team that was tracking everything out at the Cape there tonight. A fantastic job. Max, D, I believe we also had Gage trying to work one of the tracking cameras behind the scenes as well, even with technical issues. Everything absolutely gorgeous tonight on stream for everyone. Thank you, thank you. Here's an interesting question, Trevor, from 98 Central, and this goes just along with what we saw here. They're wondering if the first stage landing legs rely on gravity to deploy, what systems stabilize them after touchdown?
I have no idea. I'm assuming there's, some latching mechanism, but I have never designed a landing leg, so.
I can speculate based off of what I've seen in port, and it's those the hydraulics on the legs, I do believe, lock down once the pin opens, so the legs can come down, and yeah, gravity kind of helps that situation, but then those hydraulics in that leg are what help them put the legs back up in port. And I believe that's also kind of sort of how we get that self-leveling, is those very hydraulics. So kind of cool. And I've noticed as well, processing time in port is a little bit less because I think when they did those upgrades, they may or may not have figured out what was causing the pinch, making it hard to lift the legs. So bonus right there.
There you go. And it's worth
Remember
pointing
the
out that
days
it's...
when
Oh, go ahead.
I was gonna say, remember the days when SpaceX couldn't retract the legs and they took them off for every single recovery?
I do remember
Yup.
that. Yep.
The
And then
days when they retracted all 4 of them for the first time, we were like, "Oh my gosh, this is insane!" And now they do that like 4 times a week.
it's gotten to the point where literally the drone ships have to turn around so fast that it's a race to get them off the drone ship, and they send out the drone ship, and before you know it, it could be 24 hours later and that booster's already out of port.
Yeah, it makes it very difficult now to get a picture of the booster actually on the drone ship at this point. Most of the time, it's either hanging midair or already horizontal. It's impressive.
And kudos to Max, because Max has made it to far more return to ports than I have, because it just hasn't timed out with me for work, but gorgeous shots from Max in port there.
Yes, if you didn't see the most recent record-breaking booster that came through, yeah, that was amazing to see. We had drone shots out there, we had helicopter shots out there. It was spectacular. So definitely check that out if you haven't. There's even a YouTube short about it. And I believe it's also worth noting that per Alex in the back channel, helium pushes the leg out, the leg falls, and then it locks into place. So it is gravity in addition to helium that helps push the leg out.
I've also seen a few people asking in chat about why the exhaust is kind of blue toward the end of the burn, and that comes from the hydroxide ions in the exhaust. That when it's dark out, the intensity of the blue is just at the right level that it kind of pokes through, since the sooty atoms are not being illuminated.
I like that, the sooty atoms. The scientific term for it.
The the big ones, the like long hydrocarbon chains.
Yep. Boy. Another thing, I think. We talked about, you finally got to hear the VAB squeal, that it is not a myth. It is not the Loch Ness Monster. It is not Sasquatch. It is real.
Yeah, I
Uh,
mean, I heard it for the first time like a month ago, or maybe 2 months ago, and now I'm actually hearing it during live. So either the producers have gotten better and are remembering to fake it, or I'm actually hearing it now.
don't even mention that. You will start new conspiracy theories now. That the VAB squeal is fake. It's not. It's real. Having ask any of us that have been there to the launches, it is absolutely 100% real. What happens is, it's particular. You hear it mainly from launches from Pad 40 or landings at LZ1 and or 2 because of the direction. The frequency at which the Merlin engines resonate just so happens to resonate nicely with the panels on the side of the vehicle assembly building, to the point where you will get a squealing sound as they vibrate. So, just a fun thing to keep an ear out for each launch. But if nothing else, one thing we can keep an eye out for are some really cool launch replays, and I believe we have some of those ready. Patrick, if you don't mind, please. And we will check out the first one here. Beautiful from, again, our team at the ground there. You got Max and D out in the field. Just with the beautiful view of this particular launch here. Patrick, do we know whether this was Max or D's camera, if you don't mind me asking? We want to make sure we give him the proper shout out. I believe this is D's camera on the track. D-Wise, one of our awesome Cape team members out there as well. And look at that. And I think this will actually go with an interesting question that I saw asked here. And Kino was asking, and Trevor, I'll put this to you, why is there a white cloud formed from the engines about a minute 15 seconds into launch? So we'll be seeing that coming up shortly on screens. What exactly is it when we see that happen?
So I'll have to wait and see exactly what you're talking about, but my guess is you're seeing
Right there.
the shockwave. Okay. That's just some condensation in the atmosphere, that the atmospheric conditions are good enough or correct such that the exhaust trail is a little more visible and creates the plume. And right, sometimes this lasts longer than others. What I originally assumed that it was going to be, since right around this time the vehicle is also passing through max Q and the vehicle reaches supersonic. So sometimes you'll see the vapor cone on the front of the vehicle, but that's a different phenomena.
Right. Vapor cone doesn't necessarily mean passing the speed of sound. It's around the transonic, supersonic regime there. But yeah, typically that cloud is a good indicator, roughly, of max Q and passing through the speed of sound. Obviously, it's not exact, but it's a good idea. That's where you are in the launch itself.
Yeah, unlike the vapor cone is this vehicle is just now hitting transonic speeds, where some of the molecules are moving uh, a speed greater than the speed of sound, some are moving under, so you get this weird condensation form. But I love in this replay, you can see during this bit the exhaust going to that kind of blue, and then from orange to like purplish to blue. It's so cool.
Is it weird that it reminds me of those, like, ice pops? I don't know if it's just an American thing, where it's the red, white, and blue pops that they sell from Popsicle. I don't know why, but that's what it makes me think of color-wise.
You're not wrong. That's pretty accurate, actually.
Yeah, because you get that reddish-orange trail, the beautiful blue color, and I guess, the brightness of the white of it, so... I do wonder if that's just an American thing, though. But great views there from D for that particular launch. And again, thank you for everyone out there getting these views. Here's another fantastic shot. This one, I believe, is Max's tracking camera. Indeed it is. Max with a fantastic job, as always. To really get a good view of the color of the engines there as well, too. And just how long that engine exhaust really is. I mean, Trevor, that is not a short engine trail that we're seeing, right?
No, Sawyer, I have a question for you.
Uh-oh.
Do you think the engines are exhausted after launch?
I don't know whether to be so happy or so disappointed. I think I'll go with both. That was pretty good, actually. But yeah, and there's a really good view of that kind of like plume in the air as it speeds through flight. Just beautiful work there from Max. And you got a sigh from EJ. So. Gorgeous views, gorgeous colors here. Julia, just one final check-in with you. What was the total launch viewing experience like for you?
The total launch viewing experience was another gorgeous night launch. And to those who were watching on the coast, I hope you enjoyed it. And I know there was at least one first timer out there, and you got a beauty for your first one.
Absolutely. Now, I do see a couple people with the question, and I don't know if we have an answer to this. Matthew Scott McMillan, EJ, both saying that the second stage appeared to be dropping in altitude before SpaceX terminated transmission, noting it went from 149 to 137 kilometers. I don't know if that's normal or not, and
Yes, that is.
there you go.
Right, they start by putting it into a slightly elliptical orbit, and then they, with that second burn, which is at T plus 54 minutes or something like that, if I remember correctly, they do the mostly circularization burn, and that takes them into the 284 by 294 kilometer orbit. And then from there, the satellites raise themselves into the 530 kilometer orbit that they will be operational at.
There you go, completely normal. Just like the cool lightning show that was going on there at McGregor. Nothing to worry about there. Which, Trevor, thank you as well for joining with all of your insight tonight. It is always a pleasure to do a stream with you, for Starlink at least.
Just Starlink? That's the only time you enjoy me, Sawyer?
As long as it doesn't involve movie references, I love working with you.
No, that was a fun one. These Starlink launches, they may be routine, but they're still exciting. So it was awesome to be here answering y'all's questions. My pleasure.
Yes, they are still not always your ordinary Starlink, as we see Dee's slow motion replays here on the left side of your screen. Julia, thank you as well for joining tonight from the field.
Absolutely my pleasure.
It'll be nice to kind of enjoy these views here for a little bit longer as we just continue to enjoy the successful launch here, Starlink 6-62. Patrick is the one right now behind the scenes pushing the buttons, pulling the levers, bringing these replays to you, as well as who helped bring that launch to you as well. And then, of course, in the field, this video that you're seeing here is from D. And we also have Max out there as well. You saw some of his views as well throughout the night. They're part of our fantastic Cape team along with Julia, and I guess I'm out there occasionally, but not as fantastic as them. If you're wondering, though, wait a minute. I really wish I could see another Starlink pretty darn quickly after this one. I want another launch. Well, you're in luck. The next launch is tomorrow. Currently scheduled for 6:45 p.m. Eastern Time, and that is Starlink 6-63, and that is from LC-39A. So hopefully we will see you there. Until then, I am Sawyer Rosenstein. I have been your host for this evening. Thank you, everyone, for joining us, and have a fantastic night.
And here we go. We have liftoff.
Propulsion continues to be nominal.
R68 chamber pressure looks good.
Doubling up. Roger, planet.
Water towers fly! Yes! Tango down to nominal.
Flight downside FTE off. Say again, FTE off. Off. It's orange!
45. Oh my god! Oh my god!
Decollage.
What is it?
Put that in the big bag, you know.
343 unfolds to go.
Indeed.
We rise together back to the moon and beyond.
This methane will be igniting in the flare, correct?
Yikes. Keep red. Sure. We don't need any more of these.